Yeah, I got it. I got it. I know.
Got you.
You just let me know when you want me to start
Okay, well,
talking.
uh,
And
if anybody doesn't know, Greg is a retired professor of physics, recently retired.
I'm emeritus. I'm a professor emeritus.
Okay, you may have to explain what that means by emeritus, but
Okay. Okay. I will when we start.
Greg is going to speak tonight on restoration of what some of us lovingly call boat anchors or vintage radios. And I think specifically he's going to deal with the restoration he did of a Johnson Viking Ranger. And with that, I will turn it over to you, Greg.
Okay. Hey, thanks a lot, Jim. Professor emeritus is it's an honor thing, but the key thing is the department has to vote for you to be an emeritus professor. The president has to vote for it. There's a university committee that votes for it. But when you're a professor emeritus, you're entitled to the services and facilities of the university as available, which means, for instance, I have this beautiful Hewlett Packard workstation here, courtesy of the university, even though I am now retired. And I have access to the high-speed internet link, which is what I'm really interested in, so I can do what I'm doing right now. I do want to just mention that I've got a concert coming up on Thursday, March 10th, and it's at 7 p.m. It's on traditional Celtic and American music, and I'm being supported by the Cultural Event Series here and the University Library. And you can watch it. Just go to my YouTube channel about 15 minutes before the start time, and you'll see an icon there for the live event. Click on it, and you can watch the concert. So I just wanted you to know about that. And I think Anthony put it on the website, so everybody will know about that. Okay. And you can see I'm actually you can see the blackboard behind me. We're doing a quantum mechanics back there. But here's what I want to talk about is restoring classic gear. I don't like to call it boat anchors. I know everybody does, but a boat anchor is a useless piece of metal that is only useful for anchoring a boat. And when you get into this stuff, it's so beautifully made that it's, to me, it's works of art rather than a dead piece of equipment. And I'm kind of excited because right now I'm starting another restoration project. I have an HW101 that I have. I actually have two of them. One's for parts, one's complete, and I'm going to be working on them. And I've got the power supply and everything, so I think I'll be able to get that thing back on the air. But for this purpose, I'm going to talk about how you approach restoring and getting a piece of amateur equipment back on the air. In particular, this was a Johnson Viking Ranger. And I always like to say how I got a hold of this thing. You never know what's going to happen. I was in an 80-meter QSO with W3PH back in 2013. I mentioned that I had my own equipment I was running, tube equipment, that I like working on tube equipment. And he says, well, hey, do you want a Ranger? Okay. And I said, well, I wasn't sure what a Ranger was back then, but I gave him my email over the air, and he contacted me. And once I looked it up, I said, absolutely, I want to have one of these because this was the AM rig to have in the 1950s. This was the kind of radio that if you were running AM in the 1950s and very early 60s, this is the radio that you wanted to have. And I tried to convince him to let me pay him something for it, but he said, no, just let me give it to you. So 2 days later or so, he came by, dropped it off, and you can see what it looks like here in that picture. And it had many problems, as you can see here. This is where it is unrestored. Here the cabinet has been removed, but the weirdest thing about it was the whole center of the front dial was cut out. I don't know why this was done. They sawed this out here for some reason, and the knobs are missing all of the pointers and so on and so forth. And if you looked inside, mice had moved in to the inside. There was a mouse material inside the radio. It took quite a bit to put it back on the air. Here it is in its restored conditions. And it's in perfect, absolutely perfect electrical order. One of the things I did not do, it depends on how far you consider it over the line, is so you can still see that there are nicks and scratches on it and so forth. It's got its wear. There are companies, there are people out there who, if you take this front panel off, they will go and rescreen the whole thing for you. And to me, that's like refinishing an old piece of colonial furniture. You really shouldn't do that. These things are antiques now, and you can actually ruin the value by doing too much to it. Okay. Here are some of the problems it had. The center dial was all missing. Again, I don't know. There's a crystal cover that's supposed to go right here. I think you can see my red arrow. And that's not unusual. That cover just snaps in and it's often lost. If you have it, by God, hold on to it, because having a Ranger with a crystal cover, that's like gold. Okay. They only had room in there for 2 crystals, and it was a real pain in the butt to get crystals in and out of that socket. Okay. And I actually made an extension that I can plug into that hole so that you have the socket for the crystal outside rather than inside, so you can change it. All the white knob pointers were missing. The cabinet was a disaster. The cabinet was Star Wars blue or purple or something. I don't know what it was, but it was peeling. It was rusting. It was absolutely awful. Inside, there's a big power resistor. I'll talk about this and about these in general in a lot of radios that have these. It was totally missing. And without that, you can't run it on AM. And there was a rat's nest of wires that someone had put together to try and substitute it. Okay. And then the drive control down here was clearly broken. When you turned the drive control, it was very, very, very rough. And you could tell that there were problems there. Okay, most of the things I'm going to be talking about here are in general, regardless of the rig. Doesn't make any difference what brand of rig it is. The first thing to do, and you do not do, is you do not plug it in. The only case, if you've got a classic radio that you've gotten, you don't rush home and plug it in and see if it works. You do not do that. Unless the person says, I just had it on the air 1 month ago or 1 week ago when I was using it, and you know it's okay. One thing that really helps is if you know the lineage of the piece of equipment. Was it stored in a barn? Was it stored in a garage? Was it stored in an attic? It makes a difference. If in a barn, you never know, animals could have moved in. In my case, the first thing I did after I got the case off was just to simply vacuum out the mouse droppings and the mouse bedding. There was sawdust, straw, and of course dust and dirt. And then you remove and clean and test the tubes. And this is true in general. And one thing you might notice many times in classic radios, well, in most radios, you'll find the same number of tube used in different places. Depending on how critical the alignment is, switching tubes into different sockets can throw the alignment out. And so this is particularly in single sideband radios. So when you pull a tube out, keep track of which particular socket it came from, so you can put them all back into the same socket. That's very important. This is true in general. Testing tubes. Lots of tube testers out there, but the best way to test a tube is to replace it with a known good tube. What I try to do for all of my vintage radios is I have a set of tubes for each one. I buy them at Hamfests or get them wherever. And so that I have a separate set of tubes for each radio, so that if a problem occurs, I can just take a new tube and put it in. That's the best way. For transmitting tubes, that's really the only way you can check a final amplifier tube. You really can't check the final tubes. You can't check 6JB6s and 6146s reliably in a tube checker. They're not put under the proper conditions to really tell if they're going to work. So keeping a known good tube in stock is the best way to go. Of course, if you just got the thing, well, you don't have a set of tubes for it, and you don't know if it's going to work, so you don't know if you want to buy the tubes. If you have a tube tester, you got to be careful. The most common ones that you run into are emission testers. And these will tell you if the tube is totally dead. They'll tell you if the cathode is giving off electrons. They'll tell you if the tube is shorted, but they won't really tell you whether the tube can amplify properly, and so on and so forth. Most of the tube testers out there are of this type, okay? And of course, if you have an emission tester, you can at least look at the tube when you plug it in and see if it lights up. So it'll tell you if the filament's good or bad or something like that. The best one is if you know somebody that has what's known as a dynamic mutual conductance tester. This is a Hickok that I have, and these are very rare and they're expensive. But this type of tube tester will actually put a signal through the tube and see if it can amplify it and determine the gain of the tube. And in fact, what I do once I get a radio running is I test all of the tubes and I record the readings on the tube tester, including the gain of the tube. And then maybe once every couple of years, I'll clean the radio and then take the tubes out and test them and see how the readings compare to what they were before, so I can see if anything is aging, okay? These are expensive and hard to find. If you ever come across one at a ham fest, by gosh, snap it up. Hickoks are the very, very best. There's some ICOs out there as well, but it still comes down to the very best way is to replace the tube with a known good one. That's the absolute gold standard for checking a tube. And of course, if the tubes are shorted or something, well, then you have to somehow get a hold of them. And they're still readily available. There are places that carry tubes. You know, that's just part of the restoration, is paying the price to get a tube. Initial electrical testing, what you're really going to want to go through here before you plug it in is make sure that there's nothing shorted that might catch on fire or something when you plug it in and turn it on. If there's been mice in there, they might have chewed in on the insulation and chewed off insulation. In my case, once I got the dirt out of it, it was all clean. So they hadn't eaten anything and they hadn't chewed off insulation. They just made that their home. And I don't think they had defecated in there either. I think they just got in there where it was warm, okay? But don't plug in the tubes at first or the pilot lamps. You need to get the schematic diagram or the manual. You just have to have that, at least the schematic diagram. There are places that'll sell these, but if you check around on popular ones, you can usually find a PDF file and you can print out the manual. And see, there's the advantage of me as a professor emeritus. I can take the PDF manual, which is 255 pages on that HW101, and I can print it over there in the office, print out the manual and use the university's paper and ink, and I'm allowed to do that. Then once you got the schematic, you want to start at the AC plug and use an ohmmeter to work your way through the primary circuit to make sure that nothing is shorted or not working the way it's supposed to work. You want to use your ohmmeter, or better yet, a capacitor checker, to test the filter capacitors, okay? Electrolytic capacitors can dry out and they can also short circuit. I know for a fact that in the power supply for this HW101, two of the capacitors are shorted. And if I were to plug it in and turn it on, that would put a short circuit on the power supply and probably blow a fuse or burn something out, okay? If you use an ohmmeter and you connect it across the electrolytic capacitors, depending on the resistance scale, usually you want to go to the higher resistance scale. The meter should go down and then come back up. If it just goes down and stays down, it's probably shorted. If it doesn't go down at all, that means it probably has no capacitance or whatever. A capacitor checker is usually the best way to do it. They're available at reasonable prices. Okay, I have one. I think I paid $50 for. But here's a problem. Okay, with older ohmmeters, the ones that just that aren't electronic, the polarity on the ohmmeter leads is reversed. The red lead is negative and the black lead is positive. If you hook a diode up to it, this is how you can check it. You can hook a diode up to your ohmmeter, and if you connect the red lead to the anode and the black lead to the banded and the cathode, if it shows low resistance, then black is negative and red is positive. But if you have to flip the leaders around, then red is negative and black is positive. So when you check an electrolytic capacitor with an ohmmeter like that, you connect the black lead to the positive lead of the capacitor and the red lead to the negative. Otherwise, it won't work right. Okay, and most of the older type ohmmeters that are analog are of this type, and I actually prefer to kind of use that kind of ohmmeter. But check the capacitors to see if they're shorted or open or whatever, and if they are, then you're going to have to replace them. And I'll talk about that. You need to replace them before you plug it in and turn it on. Okay. Now, I know we've got some newcomers out there. I know we got some old timers out there. Modern gear typically runs on 12 volts. High-powered amplifiers might have 50 volts on the MOSFETs on the output. But when you go to even a small novice radio, you probably got 500, 600 volts in there. And this is very dangerous, okay? And even when the equipment is turned off, the filter capacitors can store a charge and give you a hell of a shock if you don't properly discharge them before working on the equipment, okay? You have to be aware that we're talking about hundreds of volts. I think the HW101 has 800 volts coming out of the power supply. In the Ranger, they've got 500 volts on the plates of the tube. That can give you a fatal shock. So you have to be aware that this is not solid state gear, okay? If you're not comfortable with it, then find somebody that's used to working on it and have them there the first time. And there are a couple of rules that I stick to, and that is the hands rule. I don't know if all of you have learned this or not. I see Frank smiling out there. I should say, how many of you have been zapped by one of these? Okay, the answer is yes. Okay, and if this happens with a linear amplifier with 3,000 volts on it, you're dead. The best way, though not the most convenient way, is the zero hands rule. If you're going to measure a voltage, you turn off, unplug the equipment, and you discharge the capacitors. You use a shorting stick, preferably with the low resistance in it so you don't get a surge, to make sure that everything is discharged. You use clip leads on the voltmeter. While everything's shut off and discharged, you put the voltmeter leads on, you leave the leads go, and you turn on, and then you turn on the equipment and you take the reading. And then you turn off the equipment, make sure everything's discharged, and you remove the test leads. That's the safest absolute way. Second best is the one hand rule, which is you take one hand and you keep it in your pocket at all times. Usually you're measuring a voltage with respect to ground. So again, you turn everything off and discharge the capacitors and you unplug it. Because even though the equipment is unplugged, the 120 volt line voltage usually still comes in to some parts of the inside that can shock you. So you want to unplug it. Okay. You clip on the ground lead for the voltmeter. Then you keep one hand in your pocket, and then you can poke around with the other voltmeter lead with one hand in your pocket and testing the other land. And obviously, tongue in cheek, you don't stand in a puddle of water while you're doing this, okay? But there are hams that will still do that, okay? You don't test your rig. You're anxious to work on it, and you're there in your underwear and your bare feet. You don't do that, okay? You don't do that. You do it safely, okay? And this is one of the fundamental rules that all hams learned years ago. Nowadays, it's not taught enough because people don't realize that there's such high voltages in there. Now, the hard part for this Ranger and for most transmitters and stuff, the crucial piece of the crucial part in the whole thing is the transformer, power transformer. And if the thing has been stored where it's gotten wet, or if it's been a very damp setting, the power transformer could go bad. It isn't too often, but what you want to do is try to test the transformer by itself before you check any other parts of the radio. This is true of receivers, transmitters, whatever. The best way to do this is, if you can, is to use a variac. Variac looks like this. You can get small ones for about 60 bucks. What this is, it's a variable outlet. You can dial in 120 volts all the way down to 0 volts. And ideally, what you do is when you plug the rig into this and you turn the voltage way down, and you check the voltages with the line voltage turned way down. For instance, you might set the output of this thing to 12 volts, okay? But to make sure, you have to have that schematic diagram, and you make sure the tubes are all pulled. Pilot lamps too, if you can, though they're not such a big deal. And then you have to make sure that the high voltage secondary or secondaries are truly disconnected. This might require you to disconnect and unsolder a wire. In the Ranger, the rectifiers are tubes. And it turns out if you unplug the two rectifier tubes, then the secondary of the transformer is completely disconnected from anything. But if it has solid state rectifiers, that's not going to be true. Okay, that's not going to be true. What you want to do is have the transformer secondaries disconnected from anything. All right. And once you're sure that's true, what you do is you plug in the variac and you use an AC voltmeter to set the line voltage to about 12 volts. That's about 10% of line voltage. And then very carefully, you measure all the secondary voltages on the transformer. And if you put 10% of the full voltage in, you ought to get 10% of the full voltage coming out. If there's a 600 volt secondary, it should measure 60 volts. The 12 volt secondary for the filament should measure 1.2 volts, and so on and so forth. And while you do this, it's doubtful. Watch, smell, and listen for any irregularities. Okay, you don't want anything burning or anything like that. If you catch something weird, shut it off and track it down. Okay, if you keep it down to 10%, the power is 1/100th of what it could be, and so it's not likely that anything really terrible is going to show up. Okay, now what do you do if you don't have a variac? Well, it's a couple things. You can use a filament or a train transformer. Here's a little 12 volt 3 amp transformer. You take the output of this and you run it into the 120 volt plug. So that you're putting 12 volts into the system and you proceed as before. Another thing you can do is you put a 10K 2-watt resistor in series with the AC cord. Now you're dealing with AC, so again, be careful with the hands and so forth. And what this will do is limit the current going through to the whole thing. There we go. And you can take your voltmeter, an AC voltmeter, and measure the voltage that is on the plug of the radio. It might be 6 volts, 10 volts, 24 volts. It's hard to say. But knowing what it is, you measure all the secondary voltages, and if the voltage across the plug is say 6 volts, well, that's 1/20th of 120. So all the secondary voltages should be a 20th of what they should be. If any of them are way low, there could be a short somewhere. Okay, and you don't want that to be shorted when you just bring it all the way up. Okay, you're trying to get a feel to make sure that everything is okay. And then what you do, if you got low voltages, make sure everything is truly disconnected from the high voltage secondary. Double check the filament circuits. Make sure there's no shorts in there. There could be a piece of metal or something that fell in there. A wire could be in there. Who knows? Any truly lower voltages, figure out what's going on before you apply full voltage to that transformer. Otherwise, something is going to burn up. Then you gradually increase the variac in steps. So you bring it up to 20 volts, which is 1/6. You bring it up to 60 volts, which is half. You gradually bring it up until you bring it up all the way, measuring the voltages as you go, watching, smelling, listening for any weirdness that's going on. And also be careful. Some variacs can go up to 140 volts rather than 120 volts. And you obviously don't want to put 140 volts into a 120 volt rig. The idea is to gradually bring the transformer up to full voltage and make sure that nothing's burning up or smelling, producing smoke or boiling or anything like that. You probably won't have any trouble. Okay. But you just want to be careful here. All right. And I'm in this stage right now with the HW101. I do know that at least 3 of the capacitors are bad, which means they're probably all bad. And so I'll probably take all those capacitors out, and then I can bring the transformer up and make sure that it's okay. Okay, you don't want to burn something out. If you burn something out, that could be irreplaceable. All right. Then once you get that far, at least in the Ranger, with the rectifier tubes unplugged, you plug in all of the other tubes in the radio, and then you can plug it in and turn it on, turn it up full, and see if all the tubes light. And again, make sure that nothing is smoking or doing anything funny. There are metal tubes. You got to feel them if you want to make sure that they're working. The metal tubes, you have to leave it on for a while. Make sure that the tube gets hot, okay? And you have to watch out for things. For instance, in the Ranger, and I'm sure this is true in other rigs, when I first did this, half of the tubes didn't come on. It's like, oh God, oh now what? So, oh Lord. No, I checked and I read the manual. And in the Ranger, unless you have a jumper installed between 2 pins on a 9-pin socket on the back, half of the tubes don't get filament voltage and they won't light. So you have to have that manual. You have to have read the manual to find out that you really don't have a problem at all. Okay, so just keep your head about you. Okay. Capacitor replacement. This is one of the biggies in all equipment. Is replacing filter capacitors. There's specific numbers in the Ranger, but you can use a capacitor checker and connect it across the capacitors. Usually, even though resistors are connected across the capacitor in the circuit, the capacitor checker will usually work okay. It'll still read okay. If you've got a shorted capacitor, open capacitor, whatever, it's going to have to be replaced before you can really bring everything up. I already mentioned how to check this with an ohm meter, okay? But here is the problem, that filter capacitors have changed over the last 50 or 60 years for the better. Typically, a capacitor is half the size that it used to be. And the other thing is that you may not be able to get the particular capacitor that you need, okay? In the case of the Ranger, here's an example. If you look at the schematic, they have two 15 microfarad capacitors in parallel. And they call that C90A and B. And you go, why did they just put, why did they have them in parallel? Why did they just put a 30 microfarad unit in there? The answer is, in the factory, they had a big, huge bin full of 15 microfarad units, and they said, let's use them up. And that's why they did it. So nowadays, you replace it with a single 30 unit, okay? There's another capacitor, which is like a 30 microfarad unit. You can usually go, let me see where I have it here. In general, here's what happens. Electrolytic capacitors have a paste liquid inside them. And the paste forms a molecular barrier that's extremely thin when you apply a DC voltage to the capacitor. And that little thin part is the dielectric, and then the electrolyte is one of the electrodes. The electrolyte can and does dry out over many, many years. The capacitor can work fine even if half of the electrolyte has dried out. But what often happens is, when you get the thing running again and the heat comes back on again, the heat that builds up dries out whatever is left, and eventually the capacitors dry out. And so what's usually done is all electrolytic capacitors should eventually be replaced. And this process is called recapping the radio. For popular transmitters, there are companies out there, there are hams out there who will put together a collection of all the capacitors you need for a Ranger, or all the capacitors you need for a Drake R4A receiver, all the capacitors you need for a Heathkit SB102. You can hunt around for these, okay? Or you can just do it on your own, which is what I'm going to do. One of the differences is that for filter capacitors in a power supply, it's okay for the capacitance to be higher and for the voltage to be higher. Now, you really shouldn't put a 450 volt capacitor for a 150 volt one. It should be reasonably close. But for instance, in the HW101, the filter capacitors are 125 microfarads. You can't get that. But they got 150 microfarad ones at 450 volts. Okay, that's what I'll use. They're smaller than they used to be, so you can fit a bigger capacitance still in the same spot, okay? This is not true if you were having to replace capacitors in the audio circuits. Here, the capacitors in the audio circuits affect the frequency response, and changing them to higher values can alter the frequency response of the speech section of it. So you should try to stick to the same values there, all right? Another problem is that generally 450 volt capacitors are the biggest that are currently made. You can get a 500 volt unit and you pay 3 times as much for it. All right. So for instance, in the Ranger, one of the problems is the high voltage capacitor is a 10 microfarad unit rated at 700 volts. You will not find a 10 microfarad unit at 700 volts. Forget it. You're not going to find it. Okay. But you can place 2 33 microfarad units in series, and that'll give you 16.5 microfarads at 900 volts. That's fine. But what you have to do is bridge each capacitor with a power resistor to make sure that the voltage is divided equally between them. The voltage will divide equally only if the capacitance of the 2 capacitors is exactly the same. And it usually isn't. So if you look inside of a linear amplifier, you'll see lots of capacitors placed in series with these equalizing resistors across them, and they are very important. So in this case, I simply replaced it with 2 33 microfarad units, and you can see how I mounted them. I've got a better picture here. There's a close-up of it. You can see that they're placed in series, that the resistors are right across them, and then I actually mounted this on a couple of standoff posts that I made right next to this big choke. The rule here is you got to improvise. You just got to improvise, but you want to try. And I take real pride in my work, and this will actually improve the operation of the transmitter. Okay. So you work your way around checking capacitors. If they're okay, well, then you can bring it up, but you really can't turn it all on full until the capacitors that are known to be bad have been replaced. And as I mentioned, there are companies that make kits of capacitors. As a matter of fact, for my Drake T4 transmitter power supply, there was a company that made a circuit board, and you gutted the Drake T4 power supply. You kept the power transformer and the switches, and then they had this circuit board with all brand new components on it for a very reasonable price. It's mounted in there. You hook the wires up, and it just looks slicker than snot. Just amazing. Okay, and those things are out there. Sometimes you run into a problem like this. And in the Ranger, this is a resistor that's used to apply voltage to the modulator tubes. It's a real big resistor. A lot of hams think these aren't available. Yes, they are. Yes, they are. If you go to Mouser, I found this resistor, and I replaced it, found exactly the same unit as they had 50 years ago. I was even able to find the mounting lugs and use the same holes for this to replace it and get it exact. Okay. Now, the problem with this is, this applies to many radios, this is an adjustable resistor. And you'll find a lot of these in older equipment. You can see the wires wound here that make up the resistance. And then there is this metal tap that connects to it. The problem is that these don't burn out. These are broken by the people that try to adjust them. They are broken by mistreatment. You never slide this connector unless it is totally and completely loose. You do not slide this along the resistor. That will cause it to break one of these fine wires, and if you break the wire, the resistor is useless. Now, a new resistor is about 20 bucks. So if you break the wire, you spend another 20 bucks. Also, when you tighten this down, you just need to tighten this down until this doesn't slide around. If you sit there and you tighten it all the way down, it's going to push the metal contact down in between the wires, push them apart and break them. And this is why many of these are broken, is because people don't know how to properly adjust. If you have one of these that has to be adjusted, you have to loosen this completely so that there's absolutely no friction along that resistor. By the way, this baby has got 500 or 600 volts across it. You only adjust this when the unit is shut off. You shut it off, drain all the capacitors, adjust it, turn it back on, and then you go, okay? If you make it this far, then you can plug in the rectifier tubes, hook up the transformer again or whatever, plug it in and turn it on, and watch, smell, and listen the first time to make sure that nothing starts to fry, okay? I mean, it does happen. It does happen. Oh God, you shut it off, find out what it is, okay? And make sure that everything is okay. And by the way, just pulling the rectifier tubes or not having them in there, depending on the rig, doesn't mean that the rectifiers aren't installed. Some previous ham may have hardwired silicon diodes into the power supply circuit, and those diodes are in there even if you have the plugs pulled. So you have to look at the power supply circuit and make sure that somebody hasn't put in silicon diodes. You think the thing isn't hooked up, and here it is. You got a shorted filter capacitor. You start frying the transformer, okay? Plug it in and bring it up with a very active possible. And if you make it that far, okay, you have passed a critical test, okay? This really is an important milestone. And then the next thing is read the manual. You don't have to read the construction part of a Heathkit manual or the construction part of the Ranger, but read the manual to learn how to adjust the equipment. And sometimes what you think is misbehavior is normal. So for instance, on a Ranger, I think I said here, when you turn on a Ranger and you put it in transmit mode, it's normal for the plate current meter, even if the key isn't down, to show about 50 milliamps. I won't go into the details of that, but that's totally normal. At first, I thought that was a problem. Then I read the manual. Oh, it's not. And I can tell you this, where's the best place to read the manual is put the manual in the bathroom, okay? Put the manual in the bathroom for your reading material, and that's one way to eventually get all the way through. Now, for other parts, for cabinets, what I do is I airbrush. In this case, I stripped off the old paint with strippies. And watch strippies, wear rubber gloves if you use a paint removal, because the stuff is really nasty. Strip it off until it's raw steel. And then I airbrushed it with rusty metal primer. And there's no way I could get the original color that Johnson had. So what I did is I mixed gloss black Rust-Oleum and gloss white Rust-Oleum, 2 parts black to 1 part white. And when I airbrushed it, this is what the cabinet came out looking like. It's beautiful. This is all done with a spray airbrush. And I ought to do a program on how to use an airbrush in the shop to do work like this. It's the only way to fly, okay? And I'll have a video eventually on my YouTube channel. Also, you'll notice here in this picture, most of the old gear has a 2-prong cord. This should be replaced with a proper grounded 3-prong cord, okay? And in this case, I just used an 18-3 grounded line cord that I got from a ham fest. You also need to get a strain relief for the line cord, and you probably have to drill out the hole where the old line cord came through, okay? Be very careful when you do this. I haven't done it, but I've known people to do this. They'll get there with the drill and then, oops, and the drill goes in and it just chews up all kinds of components in there. You have to be very careful if you have to enlarge the hole for the line cord that you don't tear anything up, okay? And for the fuse holder, in the case of the Ranger, this posed a problem because if you look at the back of the Ranger, there's nowhere on this back panel to mount a fuse holder. There are places here where you think you might be able to put a fuse holder there, but you can't because there's a component right there near the back panel. You can't do it. So what I had to do was fit it inside. And here are some RF chokes and stuff, but here it's kind of hard to see. I had to squeeze in a fuse holder there. It's kind of a pain because it's inside the radio. So if I blow the fuse, I got to pull the cabinet, but it's the only way I could easily fit it in there. And I used a 5-amp slow blow fuse. Seemed to work okay in this case. By the way, for those of you who wonder, those are RF chokes. Those coiled springs are RF chokes. They look like sausage curls on ladies. That's TVI prevention. And the firecrackers, those are RF chokes. Those firecrackers, I call them firecracker chokes. Notice this one here. It's discolored. Somewhere at some point, somebody shorted out the filament circuit from the plug and almost burned this thing up. Still works. So if it works, don't mess with it. Okay. There it is. Vfo Repair. Okay. I hate to say this, but in radios like the Ranger, I don't care what you do, it's going to drift. What we think of as drift nowadays was not thought of drift 50 years ago. It was normal for signals to drift and you followed each other up and down the band. As soon as single sideband came in, drift was unacceptable, and that's when all the technology had to change. But I looked at my VFO and I pretty much said, I don't care what I do with this, it's never going to be stable. Partly because they have temperature compensating capacitors, which are nearly impossible to get now. And unless you have those set right, you take a VFO, this is what's in the Ranger, and this is what's true in half of the boat anchors out there. On this side, you got two big rectifier tubes that produce heat. Over here, you got two big modulator tubes producing 50 watts of heat. Behind it, you got the final tube producing 30 watts of heat. You put all that heat around a VFO, it's going to drift. I don't care what you do. The easier thing to do is to buy an external VFO. I have one that I built myself, and I'll show you how I put this into the crystal socket. Unfortunately, you can't get the synthesizer that this is built around anymore. But what I did was I plug the VFO into the crystal socket. And if you go to my website and you look at my VFO, the techniques that you see there for interfacing that VFO to a boat anchor will probably apply to just about any boat anchor rig. And if you buy just about any solid state VFO nowadays, there are ones out there you can buy, they'll probably work. I plug my VFO in here. Okay, I plug it in right there where the crystal used to go. And I made this little holder out of a piece of plumbing fitting and an 8-pin socket so that I push it in where the crystals used to be, and I plug the VFO in there. I set this to crystal 1, and then I have digital control of the frequency on the thing. You can check this out on my website. Here's a little transformer everybody should be aware of. It's on my website. If you've got a VFO, you're trying to interface with a novice rig or something, adding this little transformer can make the difference between it working and not working. And there's also a 2-transistor amplifier that you can add. You use all of those and it'll work. I just had a guy contact me and he hooked his HG10 VFO up to an Amico AC1 and it works. Okay, so it's out there. Okay, but I gave up on the VFO. Just use a modern digital VFO. Cleaning the chassis. All right, I use a tool, a special tool I made that I precision machined that I can stick Q-tips in. Don't buy any other kind of Q-tip. The junk ones, the cotton comes off and makes a mess. Just pay up, pony up, and buy real Q-tips. I shove it in there, and then I will use naphtha lighter fluid, and I will scrub down the entire chassis using this Q-tip holder and maybe a dust cloth and some pledge. Sometimes mineral spirits. Never use acetone or lacquer thinner. Never, never. And don't get anything on the plastic meter panel. That will almost always eat it, okay? But yes, folks, it's like scrubbing the floor with a toothbrush. You work your way through the entire rig with this, and when you finally get it done, it will look like that, okay? I mean, every little square inch in here, I got at this with that, and I cleaned this all out. And if you take care of this, and I keep a dust cover on all of my radios, it'll never get dirty again. Here you can see new capacitors here. Here's a new capacitor down here I had to put in. Here are a couple of more electrolytic capacitors that had to be replaced, but it looks essentially brand new. And if you've got a Ranger, one thing I'll mention is Rangers and some other radios were available both as kits and commercially built. Well, if you go into this one and you look carefully, I don't know if I can find it here. Here's one right here. If you see, here's a terminal strip and it's riveted. If it's riveted like that, it was built at the factory. It was built at the factory. If it screws, it was probably built, it was built by a person. Rivets can cause problems. Rivets can get loose. You can always take a screw like this one here and tighten it. These screws can be tightened. These nuts can be tightened. Rivets can get loose, and if a ground connection is made through a rivet, it can become intermittent. So sometimes you go around and you spray contact cleaner on these riveted areas to make sure that they make good contact. And I can mention something, for instance, on this HW101 that I'm starting to restore. I opened it up today and I found on it a sticker. When it's a kit, you always have the possibility that somebody messed up the wiring. In my case, I'm lucky, okay, because there's a sticker on it saying Heathkit shop. It was sent to Heathkit back in '74 and probably serviced or something, and that's almost means that it did fully work properly at one time, okay? Here's an example of what you can do with airbrushing. You can see how the transformers were rusted, okay? These were rusted. And it took me a day to mask off. And look at the chassis here. This is all better than brand new. It's all better than brand new. But I masked this off with masking tape and newspaper and everything else. And then I airbrushed the transformers. I gave them a coat of rusty enamel primer while they were installed in the radio. This work was done while they were installed in the radio, and airbrush can spray the paint down in between there. And then after it dried, I turned it on and let it sit there and bake for a day, and it just baked that paint right onto it. You know, Rust-Oleum is just a great paint. Works great. Okay. What about knobs? Okay. What I do with knobs is I carefully remove them and remove set screws. This is true. I'll do this with the Heathkit. In this case, there's this little piece of plastic that was pushed into the knobs. It tends to fall out. If you've got it, pull it out and put it somewhere safe. But what I then do is I scrub these things down in water with a toothbrush and soft scrub. You get soft scrub. It's a very fine cleaner for dishes. Scrub it down, and then I polish it with Pledge furniture polish. And you see in this case, it brings it right back. And for this one, I had none of these. So I found acetoplastic, turned it on the lathe to the right size, and then shoved it in there. It also turns out there's some place where you can buy these things and cut them down and push them in too. So there's several ways to do this, to restore it, okay? Having the manual is so important. To clean the front panel and to change the light bulbs here. Where's my, where's a picture of the front panel? Let me go back to the, okay. To replace the bulbs you see here, and you see these little indicator lights here, to clean this panel and to clean this scale, what you have to do is remove the knobs here, here, and here. And then you have to get this brown part off of the front. If you have the manual, if it was a kit, you can look in the construction notes about how this thing was put together. And it turns out these little jewels here that are for the transmit light, some other use, those are what hold the front panel in place. And so what you have to do is get behind it and remove the screws that hold them. And it's hard, I don't think you can see in here very well. There's a, right there, you can see behind this indicator bulb, you can see a hole there and a nut. That nut holds that front bezel on. Never try to just take a screwdriver and just pry. Okay, I mean, in my day, I did this and I ruined plenty of things, okay? And eventually I learned that if it was put together a certain way, it could be probably reversed in an orderly fashion. There's one of these on this side and one of them way back over here. When you do that, you can finally get the thing off. And once it's removed, then you can take all the knobs off the front panel. All of this is removed, and you can clean the metal that makes up the front panel. Now, what I do is, it's one of my secrets, is you go to the auto shop and they have a Simonized, I think it's called, it's not Simonized, but they have a polishing compound for the candy apple coats you find on motorcycles and automobiles. Okay. And it's called Clear Coat Auto Polishing Compound. This stuff is just about it's white and it's just about the finest grit that you can possibly get. And if you rub that with a wet rag, small wet rag around the front, it will take a lot of the dirt off without taking any of the paint and the other stuff off. And after you go through it, here you can see that the knobs have been cleaned, the white pointers have been put in, the front panel has been cleaned and then waxed with Pledge. Pledge is one of my favorite things. After I clean the chassis with the Q-tips, I go back with Pledge and I put Pledge in everything. That does two things. It makes it shine and it stops the dust from adhering to the chassis. And I keep all of my equipment covered with dust covered. I have all of my equipment covered with white trash bags when I'm not using it, so that the best way to keep it to clean it is to never have to clean it. Okay, that's the way to do it. For this frequency scale, this was a nightmare, this plastic scale. Here, I've actually cleaned it. It had all kinds of garbage on it. It looked like it had acrylic glue on it and everything. And after I got it out, I used Q-tips and my fingernail with lighter fluid, and I was able to actually remove the blotches and all the other garbage that was on it. I don't use this on the air. I use the digital VFO. So this was strictly for looks, okay? And then I clean it and polish it with the clear coat compound. And then because the light from the lamps behind it lights it, this inner edge here would light up and look terrible. So I took flat black paint and I painted that back area there to keep it from coming through. And the result of that was that this is what, if I can show you here, here it is before, and then here it is afterwards. And as luck would have it, be aware of this, there is a company called Radio Days, I think they're still in business, that makes these parts for various radios out there. So if you've got a Johnson Ranger, you could buy, I bought this entire piece. It was about $40. Notice there's no gap here anymore. And I installed that. And if you go to my website for the Ranger, not because you have a Ranger, I have links to the parts that you can get for this. Well, there are links there to Radio Days, to Mouser Electronics, and other places that you can do. And I'm just about done here. One thing about getting parts, like when you go to, let me go back to the capacitors, and then we're going to finish up here. Replacing capacitors, okay? One of the things you will find when you buy parts is that capacitors especially, back in the day, the leads came out the ends. This is called axial leads. Nowadays, most capacitors are made to mount on printed circuit boards. And so both of the leads come out the same end. This is called radial leads. 100 microfarad, 450 volt unit with radial leads is $3.50 or $4. The cheapest you can find one with the axial leads is $12 or $25. So you buy the radial leads ones and just bend the lead around and wire it in the same way. Okay. Also, when you go to buy parts like the drive control, which is just a potentiometer, it was like a 25K 4-watt pot. Should be $3, $4. You go on the big electronic distributors and you punch in 5 watts, 25K, $60. You go, what in the world are they talking about? It turns out that nowadays the 5-watt units are the standard. A 5-watt 25K pot is smaller and it costs $3.50 instead of $60. So it's okay to go with higher wattage sometimes and different values slightly. That's part you keep the cost down. And I think with that, I think I've said everything I want to say. So are there questions out there? Hope I could hear everything here.
Greg,
Yeah.
the crystals on that crystal holder, they didn't use standard crystals and they were specifically designed for that radio, the crystals?
No, they are FT243 crystals. And what they have, and I finally figured this out after many years. Let me see here. Okay, you can see it here. The spacing, it takes standard FT243 crystals. And FT243 crystals, the spacing between the pins is 0.468 inches. And I know any sane person out there is saying, why the hell didn't they just make it 1/2 inch? Why the hell didn't they make? And I'll tell you the reason why. Because 0.468 is the spacing between the pins in an octal tube socket.
Oh,
And
so
in World War II, you didn't have to go out and make new sockets. You could just use an octal tube socket and you could plug 2 crystals into it. That's why they did it. So what's in there recessed about this far is that tube socket. And I'm telling you, you try, and it's easy enough to shove 2 crystals in there, Anthony, but then you try and get them out for absolutely forget it. So what I do, if I want to run crystal control. Well, what I'll actually do is, hold, if I find the VFO seed, what I did was I took this approach. So you can buy the octal plug from Antique Radio Supply. I believe this is a 1-inch piece of CPVC plumbing pipe. And what you do is you take an octal tube socket and you fit it into the end here. This is for the VFO input. But if I pull this out, I have one of these with an octal socket right here. And when you plug it in, the octal socket is right where you see the aluminum, and it's real easy to get the crystals in and out. Okay. But crystals were very expensive. And so they figured you only had 2 crystals and you shoved them in there, you covered it up with this nice cover, and you switched between the 2 of them. But then the price came down and it's not such a good deal. Okay. So it takes standard FT243 crystals.
So this radio could be used by novices then, because you could use it crystal controlled.
Yes. Yes. Oh yeah. Yeah. They were very, crystal control. Yes. That was one of the reasons they had the crystal control. They put it in there so that the idea being that this is a very expensive radio. So was the HW101. This was assembled. The price went up it came out in 54, and then the price went up as you went through the 50s. But at one time it was something like $359 assembled. And in 1955, $350 is the equivalent of something like $2,000 or $3,000 today. Like I think the inflation factor for the mid 60s is 8. So multiply that $340 by 8. This was the equivalent of like $2,000 or $2,500 in our modern salaries back in 1955. So a novice could buy this, use the crystal control, and then when you got your general done, you went to the VFO. But what I do whenever I use it is I plug my VFO into it, and I have digital readout, and I use VFO control.
Greg, can you stop screen share for just 1 second? I want to show people something, and then I'll give it right back to you.
Sure.
So this is an ad from Q. This is actually on your page.
Yeah, there it is at the bottom. Now this is, did I say when this is a $300 tested?
Yeah.
Okay, $300 tested. Okay, and that's probably mid 50s. That's a Ranger 1, so that's mid 50s. $300 in 1955 is one heck of a lot of money. One heck of a lot of money, and that's about what a typical Heath kit, or not a Heath kit, a typical SX100 receiver ran about $300 too. And so this was an expensive radio. This is an expensive radio. Okay.
Hey, Greg.
Yeah.
Frank here, W80ZT. The club was lucky enough to get a Ranger here as a donation several years ago.
Cool. Okay.
We sold it for I believe, was it $450, Anthony?
It was. I think
They're
it was
getting
around
expensive even on the used equipment market. Was it operational?
It was immaculate looking. If I've got some pictures here. If I could share the screen real quick.
Can you
that.
throw it up there?
Frank.
Let's see here.
Can you throw it up there? This is why I say I hate to call this a boat anchor, because these are, oh, look at that. See, yeah. See there.
This is the capacitor you were referring to.
Yeah, look at the right. Look on the right. There's a resistor over there.
Yep. And this is riveted.
Yeah, that's a factory assembled
It's a
unit.
factory. I did not realize that.
That's a
Here
factory assembled unit. Yeah, look at how clean that is. But you know, a lot of those capacitors have probably gone bad, but you never know. Oh, that's pretty clean. See, that is really clean. That's really clean. Yeah. Yeah. Modulator tubes are, keep that on there. The modulator tubes are there at mid screen on the left. The rectifier tubes are at mid screen on the right. And then the final is there at the bottom. Okay. And then the VFO is in that box in the middle. Notice it's surrounded on 3 sides by hot tubes. Okay. Oh, yeah. Oh, yeah.
Yeah, but they thought that shielding would make it so it wouldn't drift, Greg.
The heat gets it. The law of
Yeah, I know it
thermodynamics.
does.
Yeah. There you go. There's the six. Yeah. Uh-huh.
I don't know if there's serial number data, but somebody got a very good deal on that one.
Somebody told me
Let's
that they
see.
had in Waseca, Wisconsin, or wherever this thing was made, where Johnson was at the time, that they had a lot of women working in the factory that were assembling these radios.
Huh.
That a lot of ladies were assembling the radios.
Now, this particular
hurt-
radio doesn't have any of those those twist-in cap capacitors that come in from the top of the chassis.
What those things are is they're actually extensions. They're plastic extensions, which go down to the capacitors so that if you stick a screwdriver in there to adjust it, it throws the tuning of the VFO off. Mine didn't have any of those. Mine didn't have any of those. None of them. Okay. But it turns out oftentimes, no matter how much you mess with the VFO, it still drifts or it jumps around just because the capacitors get old. So I just use digital control and what the heck, you know. Other questions? Oh, those are great.
Greg,
Yeah.
can you bring that picture back up where you painted the transformers?
Yeah. Hold on here. Yeah, hold on here. Yes.
Okay, now these real little gaps between the feet where the screws are.
Yeah, right here. Wait.
Yeah,
Right.
how did you mask them off, or did you like maybe brush some Vaseline in there?
No, I masked it off. I took blue masking tape and I masked it off. It took forever
Okay.
to mask it off.
Yeah, maybe you use tweezers to get in there.
Yeah. And you can imagine going around with where's my doing all of this, doing the whole chassis here, doing the whole chassis with let's see, chassis cleaning, you know, using a Q-tip
Yeah.
to go through and clean the entire chassis here. And
Yeah, I've
actually,
done that.
I'll
I've
tell you
got
I'll tell you what I probably did is where's the transformer? I probably cut a piece of masking tape there and used the Q-tip to lay it down in between there.
Mhm.
Okay, and it's
Yeah,
not
I've got
perfect.
a SB2 221 amp, and I've cleaned it up and did some work on it. I got to recap it yet and put a couple new tubes in it. but-
The trick here is once you go to this trouble, I take white trash bags. I
Yeah.
use white trash bags or a black trash bag, and I use it as a dust cover. Every piece of equipment is covered. And a couple times through the year, rather than try and brush the dust off of the trash bags, I go down and I tell my wife, give me 3 more new clean trash bags. I give her the old ones. She uses them in the trash cans. And then I put the new ones on. Okay.
I'd be tempted to unscrew the transformers and maybe slide a piece of paper under them or something.
You might, whichever works for you, whichever works for you. But I was comfortable with this and with an airbrush. If I show you how to use an airbrush, it's quite amazing what you can do.
I need to work on that. Okay, it's a nice job.
Other questions there?
Yeah.
Most of the stuff I'm talking about here applies to all classic gear.
Yeah, Greg. Yeah, Steve, KHMS here.
Yeah, Steve.
Yeah, just a quick note, being licensed in the late 50s, you know, this was stuff I dreamed about back then.
Oh, come on. This is yeah, I know.
I ended up with a WRL Globe Chief transmitter and a Helicrafter S38D for my novice days. But yeah, this is the kind of stuff I looked in catalogs for years and like, boy, I wish I could have that.
Well, what I have is my prized possession at the moment, which is even better condition as this, is I have a set of Drake R4A and T4X that I've fully restored. And they are just really, really something. And then this HW101, I did not purchase a new radio until I was 50 years old. I could not afford to buy a new radio until I was 50 years old. And now you can find these things like, this is what I want. And what I have in my station is I like to have, I have the 50s represented with this. And then I also have a Helicrafters SX96, which I've restored. That's a typical mid 50s station. For a mid 60s, I have the Drake, but the Drake stuff is a pair of Drakes, not including the power supply including the power supply was $900 in 1965. And that is like $4,500 in our equivalent money today. I looked at that and just drooled. I mean, I had an Amico AC1 and an SX120, and that's what I lived along with.
Well, yeah, I had a SX100 I bought, just a few years ago. I bought it used, loaned it to a friend of mine and never got it back.
Oh,
what a
no.
receiver.
I don't. The SX100 is the same as the SX96, but it's a little more. The SX96, that's the dual moon receiver, was only out for about a year and a half, and then they made some improvements to it, and it became the SX100.
Right. Yeah.
Fabulous, fabulous receiver.
Yeah. Just a quick note. Nice to see Jim Felter here, KD8MOD.
Yeah, who else is in here? I haven't had a chance to look through here. Other questions?
I just wanted to mention, Greg, you mentioned the rebuild kits for the power supplies. I know somebody was marketing one for the Heathkit power supply that you have. I don't know if you could still find one of those.
Here's the problem in my case, and I got to tell you that, yes, there's the Heathkit store. I don't think he's in business now, but what I cannot figure out with this HW101 is it is the power supply, but it's not on the normal chassis. It looks like somebody took the power transformer and built from scratch an HW1 power supply. Why it's like this, I don't know. I even checked, the Heathkit part number is on the transformer. So it's actually the correct transformer for that Heathkit power supply, but it's on a small square aluminum chassis, and it's all hand built. And I cannot figure out why anybody would do this unless somebody wrecked the original power supply and decided to rebuild it. It's the correct transformer, and I'm pretty sure it's going to work. Other questions on restoration or anything there?
You ever done anything with Swan
No,
radios?
I have not. No, I have not.
I have a friend of mine that I just got him into radio a couple of years ago, and he's already got 7 of them.
Oh my gosh.
He just picked up a 600. It's a 250 watt output radio.
I see people. Go ahead.
The thing of it is, the stuff he's getting is just in wonderful shape, and people
Well,
are just getting rid of them.
Sometimes they don't know what they're worth, and I see people who have Collins. Okay, and you can go on as to who's better, Collins or Drake. In some sense, the Drake equipment is better than the Collins, and in other cases, the Collins is better. If you look inside the Drake equipment from the 60s, how it's made. They built these little sub-assemblies that they mounted inside of it, little circuit board sub-assemblies. The craftsmanship is just unbelievable. That's why I don't like to call it a boat anchor, because it is so beautiful stuff. But if you can afford it, I don't have the room. I see people that they don't have one Drake, they have 3 Drakes. They have 3 Drakes and 3 Swans and 3, I guess, whatever, that's the beauty of it. That's the beauty of it. I like working on it, I like working on the stuff.
Right, doing mostly solid state stuff. My first introduction to being shocked was one of the receivers that had the floating ground where they don't.
Oh God, yeah,
no transformer and
yeah.
nasty
Yeah,
That'll get
well,
your attention.
that is the all-American 5-tube radio. The AM radio was a design that came out in the 50s, and it used a 12BE6 converter, a 12BA6 IF amplifier, a 12AB6 audio tube, a 50C5 output tube, and it had no transformer.
35W4.
35W4 rectifier. And in the first of those radios, it's just be aware of this. The first of those radios, the chassis was directly connected to one side of the AC line, and we did not have
Holy
polarized
crap.
plugs.
Yep.
And
One random
and
size.
you could get what Anthony got, but the other problem is they got away from that, and they floated all the grounds. My S38 Helicopters has the floating ground, but they still connect to the chassis through a capacitor and for the RF return. And so a little bit of AC can get through that. So you can get a little bit of a tickle of a shock. But the other thing is that with many radios, including this type that you see here, they connected each side of the AC line through a capacitor to the chassis. If you look at the schematic, they could, if I went to the internet here, I could find it. They connected each side of the AC line through a capacitor to the chassis. And that meant that if the chassis, that forms a capacitive voltage divider. And that means under high impedance conditions, if the chassis isn't connected to an earth ground, half of the AC line voltage is present on that chassis. Now it's high impedance, so that if you touch it, it gives you a little tingle, but not too much. But if you go plugging a modern solid state VFO into that, that 60 volts can blow the input to that VFO. You got to be sure that you have that chassis connected through a 3-prong plug to ground. Otherwise, you can blow a solid state device that you try plugging into that. So you got to be careful with that kind of stuff. Yeah, everybody's been shocked. How many people have been shocked with the charge left on the capacitors? You know, I mean, you're sitting there working on it like this, you know, and you don't believe it until it happens, and it happens once, and then you learn.
Usually
know?
you learn.
Actually, I have to confess, when I was in high school in electronics class, several times we charged electrolytic capacitors and put them in the drawer of the instructor.
Oh yeah, sure. Yeah. What do you? Who's finding a schematic there?
This is, I want to just show this real quick here. This is a page I put the link for in the chat. It's a spreadsheet that I put together with radios, but the last couple tabs on this at the very end are rig reference and rig picks. And you can go to these sites for all these older equipment.
Oh yeah.
So like, this is the Helicrafters that one of these is the one I got zapped with. I can't remember which model it was. I know I had one of these, which is kind of useless. 152 to 173 AM. Or no, this is FM. I guess this was fine to receive a little bit high. But this is available. I put the link in the chat. It's tiny.cc/buy-AR-SS. Get you that whole spreadsheet. It has newer equipment on it too.
Now this is a cop radio, right? That was a cop type of radio.
Cop and police.
Yeah.
Fire too.
Anthony, can you go to my webpage there?
Yeah.
To the Ranger page?
Actually,
That's my YouTube page. Just type greglatta.com and
I had it here, but I don't have it right now.
Top line.
there you go. Go to the meter there. And just for this, go there, click on my station there just for a second. Yeah. Now see, if you look at that from left to right, This was, you can see, I've got a second from the right, I've got a 10 Tech Jupiter, and then you can see the half moon receiver that I built. That's a super heterodyne receiver. Believe it or not, that receiver, when combined with the digital signal processor, is as good as there's the Drakes. There's the Drakes there. Go all the way around. There's the SX96. And then above that is the Ranger, and that's a 50 station. See,
Greg, is this the Wingfoot?
that's the Wingfoot amplifier. Yep. The
Well,
Wingfoot.
I'm sorry, I've got to run. I'm gonna have to stop sharing
Yeah, I
because I
have to
got to
go
be
here
at a class
too
at 9
eventually.
o'clock. I got another one I have to be to. So we'll see you guys.
Bye, Anthony.
I'll stop sharing here and
Yeah, how do I go back here? I don't know.
there you
I
go.
need to get home too. There we go. Okay.
Okay,
Hey, are there
we'll
any
see you
final-
guys.
Yeah. Take care,
See you,
Anthony. Say
Anthony.
hi to Linda for me.
I will.
Hey, Anthony,
Yes.
I want to talk to you guys about train travel.
Okay. Yeah.
I want to talk to you and Linda about traveling on trains.
Yeah, and I have a slide presentation I put together too with radios and trains, but I got to run. I'll see you guys.
Okay. Okay. Go back to Jim there. Yeah. Are there any final questions?
Just one thing for you, Greg.
Yeah.
Oh, I'm sorry, Frank, go ahead.
Go ahead, Bill.
Okay. Greg, you mentioned that you could go back over and print your PDF manuals out at work still.
Yeah.
I can't do that anymore. I've been gone out of work now retired now for about 4 years. But what I found I can do with these PDFs is I'm going to hold this up to the camera. This is a thing for putting decorative plates on. It's a
Okay.
holder.
I'm watching it here. And you put the manual in that?
What I do is I take a tablet, got an old Asus transformer tablet with a PDF reader, and I set this,
Oh, that's nice.
set the tablet into the holder like so.
Yeah.
And that sits on my workbench. So while I'm working, I can flip through the pages and look at the
That's
pictures.
I can see you're a Heathkit man, right?
There are a lot of Heathkits and
I
Hallicrafters
see an
here.
SP610. I see an SP220. I see the Heathkits along the bottom. Yep. One radio is not enough.
Oh, no.
You do know the secret of the universe. The secret of the universe is the person who dies with the most toys wins. Okay. Yeah.
I think
yeah,
I'm in that competition.
Yeah. Yeah. Well, I got to go too. So thank you very much. And Jim, I'd like to do a program on airbrushing sometime.
Okay, well, I'll put that in my futures list at this
yeah,
point.
if you see what you can do with an airbrush when it comes to try to painting anything, it's the only way to go. You'll never touch a spray can again in your life.
Hey, Greg,
Yes.
one last thing before you run off. When you were doing the final smoke test, you were bringing it up slowly on a very
Yeah. Uh-huh.
I have found a very useful tool is a traditional tungsten filament 100-watt light bulb in series with the
That'll work
device.
too. That'll work too. Yeah,
And
remember I said to use a resistor, that a tungsten light bulb can work too. Some kind of a resistance to limit the current in case something is gonna blow. Okay, that works too. Yeah.
and it's a nonlinear resistor, so it's a very good device.
But
Excellent
don't try an LED.
presentation.
Don't try an LED. Someone will try an LED. and
Yeah,
say, "What
tungsten
happened?"
filament.
Yeah, yeah.
Thanks.
Okay, I'll
Thank
say
you,
I'll
Greg.
say bye to everybody then.
Thank you,
Okay.
Greg.
Thank
Take
you
care
very
now.
much,
We'll see
Greg.
you later.
Thanks,
Okay,
Greg.
bye-bye.
Jim
Good night.
Felter, I got a question for you, sir.
Yes, sir.
Are you any relation to Kenny? Kenny?
Well, my dad was a ham, KTH, and Kenny is my brother. Yeah, he passed away
Really? I know Maggie and my kids grew up with them. I
yeah,
knew
Kenny
I
had
knew-
complications with diabetes and it got him. And I just lost my sister Mary. She was down in Charleston, South Carolina 2 weeks ago. She just passed away from COVID.
Kenny's wife, Mary, and
Yeah, she
Her
passed away
father-
too. They're all, everyone's
Yeah.
passing on.
I
Yeah.
saw your last name and I thought, boy, that looks like Kenny.
Yeah, Ken wasn't a hand. He was a fisherman.
Yeah, I met him actually roller skating out at State 8. Long.
Did you know Ken Steyer?
Yeah.
Okay.
I
And
know Floyd may be in here. I don't know if he is tonight or not.
but I roller skated out there. I actually worked at that rink for 5
Yeah,
years.
yeah, Pat, do you want to turn the recording off?
Oh, that'd be probably be a good idea. Yeah.
And I would mention to everybody, if